This is an alternative version of one of the threaded parts of my sash clamp. These parts, the original ones, were meant to print sitting on the print bed like this, and they were printed in one piece. Now I know of at least one instance where somebody had printed one of these out of PLA. If you look closely at the way the layer lines are oriented, this is also a point of stress concentration, and it broke across where the bolt goes through on their copy. I've never had that happen with the PETG ones, and as you may have seen in my recent video, I had that go up to quite a significant poundage, 240 pounds. In any case, I set about developing another different version where I had it so that it would bolt together and be able to be made in two pieces, each of which could be made laying flat on the print bed. That way the layer lines are all perpendicular to the force that's being applied. I'm going to apply some wax to the threads. I can get a little bit more torque on it that way, a little more force rather. Less is lost to friction. So I'm going to try this one out and see if I can get more weight or more clamping force than I could with the version that was made in one piece, or less. It just depends on whether this bolted together construction can stand up to it. This very first version, I only had 2 bolts, and with the force applied, I kind of think this might have a tendency to splay. So I'm going to test this one as well. But first things first, I'm going to go with the one that I'm sure is going to be good, the one with 4 bolts. Okay. That's as hard as I want to squeeze it. 272 pounds. Not bad. So now I'm trying it out with the 2-bolt version. And yeah, I can see as I'm applying force here, let me change where the camera view is, starting to spread even at only 130 pounds. I mean, that's more than you can get with like a squeezy hand clamp usually, but yeah. Yeah, that's starting to creak. That's about to go fail, but that's 240 pounds. Okay, I got the single piece version loaded up with the load cell loaded up and just a little bit of force applied so far. Also, I'll point out, I finally got around to designing some simple feet to keep this upright. The last one I didn't have enough, I didn't print enough of them, but I just was supporting it in my vise. And I might end up doing that again with this for this test because of the amount of tension I'm putting on it. We'll see. Yeah, in order to get this done with 2 hands, I'm going to have to move this to the vise. So let's just take care of that now. Read that? Yeah. There's 271. I'm calling it there. Okay, I've got it all set up now with my older design that uses a captured nut and a threaded rod. This is available. This one is a half 13, but is also available for M12. Now I fully expect this one to actually exert considerably more force. So we might end up with a failure on this part. The reason I'm saying that is that with the finer thread pitch, it'll take longer to exert the force, but it's going to have so much more mechanical advantage. And the metal on metal threads, I would expect to have less friction than even my waxed plastic on plastic ones. But that's just my expectation. We're going to find out, aren't we? It's quieter. And yeah, it is taking quite a bit longer to get up to force. Okay, actually, I'm quite surprised. This is taking just as much effort and hurting my hands just as much to get to that 270 pounds. So, interesting.